Okay, so it's no secret that we ran into a roadblock today in class when we were trying to finish off this limit. Let me get you to where we got stuck, and then I'll show you how we're going to get out of this. And then, when I see you next, you can, let me know what you think. Okay, so when we started this problem, we were given the hint that we were going to multiply by a form of 1 so that we could get a common denominator. And so let me just write that down. We multiplied x minus the square root of x squared plus x by x plus the square root of x squared plus x over x plus the square root of x squared plus x. And when we did that, we ended up with x squared minus x over x plus the square root of x squared plus x. And then when we simplify that, I'll squeeze it in at the bottom here, limit as x approaches infinity of negative x over x plus the square root of x squared plus x. And many of you made it this far, did a good job, and you're now ready to take this limit using L'Hopital's rule, because this turns into an indeterminate form. It's basically a negative infinity over infinity, right? And we know that's indeterminate, so we're going to use L'Hopital's rule. I'll shift over to a blank screen and we'll pick up there, because that's where things started to fall apart a little bit for us. So just by getting this common denominator, we end up with a rational function, and the limit is currently indeterminate, so we're going to apply L'Hopital's rule, which says that we can take the derivative on top and bottom, and the limit has the same value. So our limit, as x approaches infinity, is of the derivative on top is negative 1, and then we said the derivative on bottom was 1 plus, and that's where we had the old 2x plus 1, because of the chain rule, over 2 square root of x squared plus x. Okay, so that was pretty good. If you made it here, you've done pretty well. The problem is that this little fraction on the bottom is still indeterminate, right? It's still an infinity over infinity, and that is a sad face because it means we're not ready to finish this thing off yet. So the question is there a way to turn this into something that we can evaluate the limit? And we took a sneak peek at the notes, and we found out that yes, that this thing can be manipulated so that it does turn into something that we can evaluate. So I'm going to run through the algebra that it takes to get there. And keep in mind, the reason that I know I have to do this is because right now this fraction still has infinity over infinity. Before I think about taking using L'Hopital's rule again, I'm going to see if I can manipulate that with algebra. And it turns out I can. It's not necessarily easy or pretty, although I'll call it beautiful. But it is necessary, and it's something that we are capable of dealing with. So at this point, what I'm going to try and do is turn this thing into one big radical expression, one big square root, if you will. And to do that, what I'm going to do is I'm going to first deal with this 2. I'm going to get that 2 inside this radical. After I achieve that, I'm going to deal with the 2x plus 1, and I'm going to get that binomial underneath a radical. Once I have a radical on top and a radical on bottom, I can turn it into one big radical, and then we're ready to roll. It's a big radical party. Okay, phase 1, I'm going to deal with the 2 in the denominator, and that goes something like this. The limit as x approaches infinity of negative 1, I'm not messing with that. 1, I'm not messing with that. 2x plus 1, I'm not messing with that. But I think you'll agree that I can rewrite the value 2 as the square root of 4 times the square root of x squared plus x. And now I hope you can see that I can multiply these two radical expressions together, and that denominator, becomes the square root of 4x squared plus 4x. When I rewrite this on the next screen, that will be on the denominator. This expression will be there. And then we'll go for the next phase. So on the last screen, we ended with this expression. Notice I did put that radical in, as I mentioned. If you hear music in the background, it's out in the hallway. There's nothing I can do about that. Let's move on to phase 2, which is that I am going to put this thing under a square root. And the way I'm going to do that is I'm going to square it and then put a radical around it. Now, when you square this, you have to distribute, and that is really the square root of 4x squared plus 4x plus 1, right? When you multiply that binomial out. So now we have the limit as x approaches infinity of still negative 1 over still a 1 plus a square root of 4x squared plus 4x plus 1 over a square root of 4x squared plus 4x. That's a 4x up there. Sorry if you've been cursing my name for the last 3 minutes while I talked. I apologize. Actually, it's only been a minute 12, so there you have it. Okay, 4x squared plus 4x. Now, because of the rules of square roots and radicals, we can turn this into one big giant radical expression, and that's what I'm going to do on the next line. I'm taking it one step at a time here, mainly because I'm so happy that I figured this out, although I am discouraged that I figured it out about 40 minutes late. It's like the time I left the papers in the bathroom for 40 minutes. Stuff happens when you get old. Okay, so this is one big radical expression. And I know that it looks a little bit intimidating, but this is really, really awesome because it's going to allow me to manipulate this thing so we can take the limit, and we won't even have to do another L'Hopital's rule. We could if we wanted, I suppose. Okay, so there's the big, giant radical. Now, it would be nice if I could just cancel these out, right? But we know those are world breakers. You can't just cross out 4x squared and 4x. Huge no-no. But some people will do that, and they'll say that it's negative 1 over 1 plus 1, and they'll get the right answer, right? We already graphed it. We know that the limit is negative 1/2. But that's just so wrong. Please don't do that. Here's what we can do instead. We can split this into two fractions. We can put this over 4x squared plus 4x, and we can put this over 4x squared plus 4x. And as soon as we do that, we have it. All right? Again, we need one more screen, but we're going to get it. So what I've done here is I've turned the large fraction into the sum of two less large fractions. We actually do call that partial fraction decomposition, sort of. But really, I've just split it into two fractions. And why is that awesome? It's awesome because this turns into a big, huge 1. And at this point, we can do this limit. Check out how cool this looks. Square root of 1 plus 1 over 4x squared plus 4x. It's awesome because now I can do my substitution, right? I can substitute infinity in for these x's. We know that means this heads to 0 because we've proven that before. And lo and behold, we get negative 1 over 1 plus 1, which is 2. And this works out to be the value that we demonstrated when we did the graph. It was not easy to get here, and there probably were ways we could have used L'Hopital's rule in between while we were doing this. But once I got started on a roll with the algebra and I figured that I needed to redeem myself, I wanted to stick with it. So take this video for what it is. It's an explanation of how to finish that problem off. Cheat off me, copy this down, use it. we're going to chalk it up to experience. That was one of those problems that was supposed to be challenging, that was supposed to test your skills. As you can see, it tested mine a little bit. So we're going to learn from that, and we're going to move on. Good luck with the rest of the work, and I'll see you soon.